analytical geometry, write today's date on for me. Okay, now analytical geometry is just a fancy word for saying coordinate geometry. Okay, so it's actually good we're doing this because we're still going to be working on a Cartesian plane. Okay, right, so analytical geometry, also known as coordinate geometry, same thing. Okay, and then geometry is obviously what? Using what? Shapes. Okay, shapes. Right, so we're going to be working with shapes, different types of shapes. Very important is you need to know your properties of shapes. Okay, you know our quadrilaterals? Okay, we need to know our properties of quadrilaterals, but which we will get to. That is going to be self-study, because if you don't know your properties by now, then, yeah, I don't know. Okay, so you guys are going to have to go and study your properties. I do think I'm going to set up a little class test on the properties so I can kind of force you to study. Okay. Right, so in analytical geometry, we have got 3 different formulas that are very important. Okay. These formulas you need to what, do you think? What do you think I'm going to write in red? That's it. Okay. I'm not going to give them to you. Okay, so please know these formulas off by heart. Okay, please know these formulas off by heart. Okay, the next thing I'm going to say is these 3 formulas are always going to work with 2 coordinates given at least. So you can't use any of these formulas unless you have enough information, okay, or unless 2 coordinates are given. To calculate the distance, you need 2 points. Okay, do you understand? To calculate the gradient, you need 2 points. Right, so we're going to start off with the first equation, or the first formula, which is our, what is that? This looks familiar. What is that? Okay, that's it. So this is our gradient formula. Let's write that down. Okay, we already know how to calculate the gradient from the linear function. And again, now listen to me carefully. Using color in analytical geometry is going to help you, because you are going to start confusing your coordinates, I can promise you that. Okay, so we're going to have 2 coordinates given. We're going to have A and B, for example. We know A is going to be made up of x1 and y1, and B's coordinate will be x2 and y2. x2 and y2, yes, remember, okay. Whichever coordinate you pick as number 1 and number 2, it's fine. We're just going to have to be careful of our signs, okay, but we'll land up with the same answer. Okay, so we've got x1 and x2. I'll highlight that in one color so I know they go in the right place. And I've got y1 and y2. Okay, so we know with gradients, the gradients of line AB, to calculate the gradient is going to be y2 minus y1 over x2 minus x1. We know that my y values go at the top, and we know that my x values go at the bottom. Okay, another thing that's very important for you guys to remember about the gradient. What else do we know about the gradient? Of parallel lines, they are the same. I showed you that yesterday. So the gradients of the 2 lines will be the same if they're parallel. And if they're perpendicular, when we multiply the 2 gradients, it must give me negative 1. Okay, anything new so far? No. Okay. Hold on. The next formula is the midpoint formula. Midpoint formula. Okay. And obviously, now listen to me carefully. If I give you, here's my ruler. Okay, let's just say I'm going to draw something at the bottom here for you. Okay, so here's a line, for example. They give you point A, which is x1 and y1. Are you with me? And they give you point B, which is x2 and y2. My question is going to be, calculate the midpoint. Okay, now the midpoint is also made up of a coordinate. Okay, midpoint 1, midpoint 2. Same thing. Okay, it's also made up of a coordinate, x and y. Okay, so what's going to happen is the midpoint formula is then written as a coordinate. Okay, can I move up? Okay, so can you see my midpoint is written as a coordinate? There it is there. Can you see? Okay, now let's make a note of that. M is a midpoint, but it's written as a coordinate. Okay, and my formula to go and calculate my midpoint is we're going to take my two values of my coordinate, my x values. We're going to add them together and we're going to divide it by 2. It will always stay this way, grade 10s. If I ask you to calculate the midpoint, this is the formula you're going to use. Okay. And to calculate my y part of my midpoint coordinates, it's going to be, okay, let's fix this quickly. This is supposed to be a 1. Okay. And we're going to divide it by 2. Okay, do we understand? Right. Right, and lastly is our distance formula. Okay, our distance formula. And again, distance formula is always going to be written as the following. It will never change. All we're going to do is we're going to take the square root of, so we're going to subtract my x's and we're going to square it. We are going to subtract my y's and we are going to square it. We then add those two answers together and we'll square root our final answer. Okay, so yes, it's a lot, but you guys need to study. Okay. Right, can distance ever be negative? Okay, can you ever say how far is it to Durban? Oh, it's about negative. Yeah, whatever. I don't even know how far Durban is, but you get what I'm saying. Okay, do you see what it says over here? You must know the formulas. Okay, you guys okay? Right, let's move on. Let's move to okay, so quickly, I'm going to do this with you. Yeah. Okay, so they give us two coordinates here. Can you see? Right, obviously it's not going to be so easy. Okay, but remember we need to learn to call before we start running. Okay, so we've got two coordinates. Before I even begin, I go and highlight my x's in the same color, and I go highlight my y's in the same color. It's going to help me, yes. Okay, now the question is, given the following two coordinates, go and calculate the gradient of xy. Now you need to know, what is my gradient formula? M, so the gradient, look here, of which coordinates do we want? Okay, so my gradient of line xy is going to be the following. y2 minus y1 over x2 minus x1. Okay, so what I'm also going to do is I'm going to go and label my first coordinates and my second coordinates. Okay, I'm just going to pick x as my first one. Okay, so I'll make this one x1 and y1, and I'll make this x2 and y2. Right, so what is my value for y2? 6. Okay, so we're going to have, you guys need to focus. Okay, so 6 minus from the formula, but what is my y1's value? Okay, so we need to bracket this, honey, yes. Okay, hold on. Okay, Okay, then x2. Now do you see, because I've made this y2, I need to start here with the x's as well. You can't now want to jump from this uncle to this auntie B. It needs to be the same. Okay, so we're going to start here. x2 is 3 and x1 is negative 2. So we're going to have to double negative as well. Eh? So negative bracket negative 2. Are you with me? Okay, so this is going to be 6 plus 3 divided by 3 plus 2. Okay, I'll just continue up here. Okay, so I'm going to have 9 over 5. You can leave it like that, or you're more than welcome to change it to a decimal or a mixed fraction. Okay, other way. Okay, yes. Okay, next I want us to calculate the midpoint. Okay, so we know it's going to be a coordinate, eh? Yes. Okay, so my midpoint of x and y is going to be the following. You see how I write it as a coordinate tab? You see the difference? Yes. You see the difference? And that is small m or big? Yes. No, I don't know. Yeah. No. Same thing. Yeah, same thing. Okay, and what is my formula? x1 plus x2 divided by 2. Okay, it's a coordinate. What's this thing called? A semicolon. Yes, look at me. Okay, y1 plus y2 over 2. Okay, what is my first x coordinate? x1 is negative 2. Are you with me? Yes, up here. I'm still using this one. Okay, so x1's value is negative 2. What is x2's value? 3. So I'm going to plus 3 here. Okay. And then, what is y1's value? Negative 3. And what is y2's value? Okay, plus 6. You guys okay? So, okay, so this is going to be a half and 3 over 2. Okay, there's the midpoint. There's the coordinates of the midpoint. So then you don't have to... No. If you want to, you're more than welcome to. Okay, my distance. Distance of xy. Okay, what's my formula? The square root of x. Okay, so it's x2 minus x1. We square it. Okay? We need to add it to y2 minus y1 squared. Okay, so lots of formulas to study. Okay, grade 10s. You need to know which formula is for which. Okay, you guys okay? Okay, what is x2's value? Okay, 3. What is x1's value? Okay, so we need to double negative, close your bracket, and square it. Can you see? Are you fine? Okay, then what is y2's value? 6. And what is y1's value? Okay, so we need to double bracket, close your bracket, and square. Yeah? Yeah? You need to bracket, and then you need to close your bracket. Okay, now do you see, by us squaring, it takes the negative away, because can you ever have a negative under square root? No. So do you see, by squaring, we get rid of that negative. Okay. Right, so this is going to be 3 plus 2, which is, okay, 5 squared, plus 6 plus 3 squared is, okay, so it's 9 squared. Are you guys with me? positive. Okay, remember that represents multiplication. Okay, the brackets, yeah. Okay, so this is going to be the square root of 25 plus 81. Okay, you guys fine? Okay, 25 plus 81 gives me the square root of 106. You leave it like that, or you can push S to D, okay, which is 10.30 units. Okay.